Hello, and welcome to the fourth part of this video. You can see we're in a different angle because now I'm actually going to be typing on my computer and demoing a little bit of Git stuff. So if you're like most students in this class, you've probably been very confused by Git. Git, for those of you out there who like British culture, right, is named after, a British word basically that means idiot, which is kind of how the whole system makes you feel whenever you try to use it. So I'll just be showing you now some of the basic things about Git and kind of going through a little bit indirectly this final question and hopefully clarifying some of the things. So in this class, you can totally have a skeletal knowledge of Git and just know like push pull, but hopefully we can explain a little bit better what's going on here. So it's basically talking in this question about some of the commands and telling you to CRC which one allows you to do whatever you want. So I'm just going to kind of indirectly show you what these commands do. So basically, I'm on my desktop right now. You can see I have some pirated films on there that I was watching and some other stuff, some videos of the previous things I just made. But anyways, I'm going to show you what Git's actually going to do. So I'm just going to create a little folder, folder called demo right now, which is just where I'm going to be doing these operations. I'm going to cd into it, so I'm going to go into it. So if I do ls in the folder, notice I just made it, there's nothing in here. If I do ls-a, all that's in here is dot and dot dot. That's basically just a reference to the folder itself and the parent, right? Which is why you can say cd dot dot, and it brings you back to your desktop. That's what the dot dot means. Anyways, so notice that there's only this dot and dot dot in here. ls-a also shows hidden folders, by the way, which is why they appear here. So the first thing I'm going to do is I'm going to go and do git init. We'll say you initialize an empty Git repository in this demo folder. So if I do ls, there's still nothing there. But now if I do ls-a, which shows me hidden folders, you'll see there's this .git folder. And that's all it means to init a repo, is you put this .git folder in here. I wanted to take a moment here to distinguish Git and GitHub. Git itself is not connected to the internet. It is just a version control system. GitHub is where we actually like host things. And we're not talking about GitHub right now. We're only talking about Git. So this is all local. This is all on your computer. If you delete this .git folder, it is no longer a repo, right? And there's no like online backup or anything. Anyways, so let's look at the kind of purpose of Git right now. So let's say that I create a file. I'm going to call it touch hello.txt. Touch is the command for creating file. I don't know why it is. If I do ls, you now see that hello is in there. And if I cat hello, which just shows me the contents, it comes back empty because there's no contents in hello.txt. So let's say I put some contents in. I want to echo the word hi into hello.txt. Don't worry about all these commands if you're not familiar. All this means is that I am putting the word hi with an exclamation point into this file called hello.txt. So if I cat it now, you'll see hello.txt. It just shows me hi because that's what's in here. Okay. So let's see what's happened in terms of Git. So if I run git status, this will show me you haven't made any commits yet because all I did was init. I haven't made any commits. And there's an untracked file, right? Because I created this hello.txt file and I haven't added it to Git. So Git sees that there's this file in here, but it's not being tracked yet. If I want to start tracking something, I do git add and I can add hello.txt. Nothing is saved yet. All I've done is I've said, told Git that there is a file, it's called hello, and you should start tracking it. So if I run git status, you will see correspondingly, there are no commits yet because I haven't saved anything, but there is a change to be committed. It's this file, it's called hello.txt. So saving something in Git is a two-step process. First you add it, right? And then you commit it. So now that I've added this file, I can commit it. Go git commit -m just for message, and the message I want to include is pp. So if I do that, it will say, great, I have this commit, it's named pp. And it basically is just saying, yes, you've created this commit. So again, let's run git status. Git status is just saying now there's nothing to commit because I did just commit all of my changes. Working tree is clean because I've committed all my changes, right? So now what you can do is, let's say, remember that hello is still, or hello.txt still contains hi. Let's say I want to change it. So let's say I say howdy, and I put howdy into hello.txt. If I cat hello.txt, you'll see it now says howdy. It no longer says hi. So then let's say I go through the same process again. I add it, and then I commit it, And this time I name the commit poo-poo instead of pp. Git status, it will say working tree clean. And now if I cat hello.txt, it says howdy, right? But remember we saved earlier when it said hi, not howdy. So if I run git log, you can see here I have two commits. One is poo-poo and one is pp, right? This is the first commit we made. This is the second commit we made. So let's say that I don't like my changes in the poo-poo commit. I don't like that it says howdy. I want to go back to the previous version. And this could be a previous version of your code or whatever. All you have to do is say git checkout, give it the commit ID. So this is the commit ID. I'm just shortening it here. You can just put the first couple characters because we'll auto-complete the rest. And then I want to check out hello.txt. It will say updated one path. And so now if I do cat hello, you see that we're back to the version that said hi. We're back to the version that was saved when I did this commit. I could also say git checkout and go back here and change it back and forth, basically. That's generally how you would use Git. So now let's look at these questions here. Tell Git to start tracking a file. Well, we just add it, right? That's what when you track a file or you want to update a file, you add it. When you want to save a snapshot, in other words, save that change, then you would commit it. So remember, commit saving is a two-step process. First you add, then you commit. If you try to commit without adding, it won't do anything because it won't know that there's an updated version. You have to tell it, hey, I've updated the version, and then you tell it to actually save. See what files have changed since your last commit. Well, that is git status. You saw me using that a lot just to verify, yes, has there been a change made? Should there be a change made, etc. And then list of previous commits. You saw me do that here. It's git log. Okay, so now we're going to get into the part that's a little bit spicier. I'm going to switch to my iPad so I can draw this out a little bit. 1 second. Okay, great. You should be able to see that now. So we're talking about this part now where we want to create a copy of a remote repository and send locally tracked files to remote repository. So what does that mean? So here's basically where we go from just Git on your local computer to GitHub. So here's GitHub, basically. And here's, your computer. Right? So GitHub is hosted on some servers somewhere else. Your computer is right in front of you right now. You're probably watching this video on it. So basically what happens is when you create a repo, you create it locally on your computer. So let's say this circle is your repo. This is, for example, the circle that I just created when I said git init in my demo folder. I create a little repo. GitHub is not aware of this, right? So if you delete this off your computer, it's gone. There's no record of it anywhere. It's not hooked up to the internet. You don't need the internet to hook it up. However, GitHub allows us to use the internet to transfer code between multiple computers. That's how you fetch the skeleton files every time you want to start a new project or lab. It's how we grade your work because you have to send it over to us and then we pull it from GitHub. Right? Okay, so basically what happens is you have a repo online. So when you did your Beacon registration at the very beginning of the semester, you got like your course number, you took like a little quiz or something. I still haven't done it, I need to. Basically what that did is it created a repo on GitHub, right? Not on your computer, but on GitHub. You don't have it on your computer yet. So what you need to do, and this is the answer to that 5th question on the worksheet, is you need to create a copy of this repo onto your computer so you can change it. You may have noticed you can't directly edit files on GitHub. You can look at files, but you can't edit them. You have to clone them to your computer if you want to edit them. So what you do is you run the command git clone, and you then put a URL that is from GitHub on that. And what that's going to do is it is going to clone this repo from GitHub onto your computer. Notice it's going to clone it. So the second you clone it, these are now kind of different repos, right? If you make a change here, it's not automatically going to be reflected here. It's a clone. It's not like a link to it. It is just a carbon copy, to use the outdated term, a mimeograph, if you will. Okay, so when you want to make a copy of a remote repository, you use git clone. That's the answer to that part of the worksheet, right? This is a remote repository because it's remote. It's not on your computer. Okay, so then let's say you want to change some files. So let's say you make some changes here and here, etc., whatever. remember that GitHub doesn't know you made the changes, right? Because Git itself is totally offline. It's just a copy of it on your computer. So, but of course, you might want to update the remote repository. You want to update GitHub because when we pull your code, we're pulling it from the remote repo. So if you want anything graded, you have to do that. So what do? You make your edits, and then let's say you do some adds, you do some commits like we were doing before on this local repo. This local repo is now different than the GitHub repo. Then what you do is you run git push. And what git push is going to do is it's going to take this repo and it's basically going to send it here. It's going to modify the repo on GitHub so that it looks the same as the repo on your local computer, right? And then if, we, for example, at the staff, have the auto grader, and we want to run the auto grader on some code, we are going to run a git pull, get your remote repo, and then we're going to run that on the auto grader. So hopefully you can see there's this system here, right? So GitHub is kind of the last source of truth, but it only updates once you push. So that's the final answer to the worksheet, is send your locally tracked files to the remote repository. I don't know why it says locally tracked. It just means basically send any updates, right? So GitHub is the middleman between us grading your work and you actually writing it. So I hope that makes some sense. That is how you basically do all of these things. So that is the first worksheet, regular worksheet or whatever. I hope this video has been somewhat useful to you, and goodbye.